Alright, so in this lesson we are going to move along with our rational polynomial expressions, and we are now going to add and subtract. So the sub-skills that you need for that is to be able to factor still. When we add and subtract fractions, we always need a common denominator, but now we're going to apply that to polynomials. And to be able to multiply polynomials and then simplify. So here we go. So by the end of this lesson, you should be able to take these two expressions and to be able to add or subtract them and simplify. So to get our bearing straight in adding and subtracting fractions that have polynomials, we're going to go back and revisit what it's like to subtract or add just a fraction, just like we did in elementary school. So I have 4/9 and I'm taking away 1/2. So 4/9 is a little bit less than half, and I'm going to take away a half. So I'm going to end up with a negative number. But in order to add or subtract fractions, hopefully you remember I need a common denominator. So when I think about 9 and 2 with a denominator that they have in common, 18 is going to be the smallest number that they both can be. So to make 9 18, I would multiply by 2, and to keep the fraction equivalent, what I do to the bottom, I have to do to the top. So 8/18 is the same as 4/9. And then 1/2, to get 2 to be 18, I would multiply it by 9, so I end up with 9/18. And now you can either think of it as 8 minus 9, or for this, it's easier to kind of think about it as subtracting is the same as adding the opposite. And so we would end up with 8 plus negative 9, or 8 minus 9, and that gives me negative 1/18. And that is my simplest fraction. So as we move through this process, here are my guiding questions that I use when I'm thinking through adding and subtracting rational expressions. It's a little bit more intensive than multiplying and dividing. So first of all, we're going to start by factoring the denominators. So we only want to work with the denominators to begin with, because to add or subtract fractions, we have to have a common denominator. And then once I've factored the denominator, I need to determine what my common denominator would be. And then I need to make sure, just like we did with the 4/9, we had to multiply the bottom by 2, so I also had to multiply the top by 2. So thinking about how can I keep that fraction equivalent. And then I need to think about if I'm adding or subtracting. And then I'm going to add or subtract my numerator and combine like terms. And then I always want to go one step further and see if I can factor the numerator, because sometimes that can cancel with something in the denominator. So for instance, if I had ended up with 2/4, I could simplify that to 1/2. So it's that same idea here. And then what's my final fraction? Alright, so let's go ahead and get started. So the first question is, can I factor any of the denominators? Well, this denominator over here is already a monomial, so it cannot be factored. However, I can rewrite 2m as 2 times m plus 4. Alright, so can I factor? So then the second question is, what would my common denominator be? So what's important is that my LCD, my least common denominator, includes something that all of them have. So if I look at this, I have a 2 and I have a 2. So they both share a 2, so that's good. Over here I have an m. This one does not have an m. So there has to be an m in the denominator. And then this one has an m plus 4. And the other one does not have the m plus 4. So the least common denominator is by taking all the things that they have and putting them together. And sometimes they'll share things, and then sometimes they don't. So my common denominator is 2m times m plus 4. And then the third question is, what, if any, part of the common denominator does each fraction need? So, for instance, when I look at 2 times m plus 4 is the denominator over here. So it has the 2 and it has the m plus 4, it just needs the m. And what I do to the bottom, I have to do to the top. Alright, so then when I look over here at my denominator 2m, it has the 2 and it has the m, it just needs the m plus 4. So I'm going to multiply this by m plus 4, and I'm going to multiply this by m plus 4. All right, so now I have my common denominator. So am I adding or subtracting? I'm adding. So adding makes my life easier because I don't have to distribute a negative. And what's my simplified numerator? So first of all, I'm going to multiply this. So I have 3m squared. And then I'm going to need to multiply m minus 2 times m plus 4. So I'm going to distribute. So I have plus m squared plus 4m. And then I'm going to distribute my negative 2. So minus 2m minus 8, and that is all over my denominator of 2m times m plus 4. All right, but I need to simplify this. So I can add 3m squared and m squared. So that gives me 4m squared, and then I can put together 4 minus 2 is 2m minus 8. And that's all over 2m times m plus 4. So my simplified numerator is that. So then I need to, so that is my answer. I've added the two fractions, but we always want to see if we can simplify. So I'm going to see if I can factor the numerator. So one of the things I noticed is that I could take an m out, or I'm sorry, I could take a 2 out. So if I take a 2 out, I'm left with 2m squared plus m minus 4, and so I have to see if I can factor 2m squared plus m minus 4. So I would multiply a times c, and I would get negative 8. Are there any factors of negative 8 that give me 1? And there aren't. So I cannot factor 2m squared plus m minus 4 any further. But my next question is, can I cancel anything with the denominator? And so if you notice, I have a 2 here and a 2 here. So those will cancel. And so my final fraction is 2m squared plus m minus 4 over m times m plus 4. And that is my final answer. All right, so let's look at example 2. Can I factor any of the numerator can I factor any of the denominators? Well, this denominator is already factor, or as simple as it can get, and so is that denominator. So what would my common denominator be? Well, my least common denominator is going to be x plus 3 times x minus 2. Because I cannot multiply anything by x plus 3 to make it look like x minus 2, and I can't multiply anything by x minus 2 to make it look like x plus 3, so my least common denominator is just the 2 together. All right, what if any part of the common denominator does each fraction need? So the part on the left already has the x plus 3, so it just needs the x minus 2. And what I do to the denominator, I have to do to the numerator. And then the other one is just missing the x plus 3. It has the x minus 2 parts. All right. So am I adding or subtracting? I'm adding, so that makes my life easier. And what is my simplified numerator? So I'm going to distribute out the 5 to the x minus 2. So I have 5x minus 10. And then I'm going to distribute out the 3 to the x plus 3. So I have plus 3x plus 9, and then my denominator of x minus 2, x plus 3. All right, so then I'm going to combine my like terms. So 5x and 3x makes 8x, and negative 10 plus 9 makes negative 1 over x minus 2, x plus 3. All right, so can I factor the numerator? No, I cannot. So there's nothing that can cancel because there's no way I can factor x minus 8 or 8x minus 1, and so there would have to be an 8x minus 1 in the denominator cancel. So that is my final answer. All right, so we're going to work through example 3. Can I factor any of the denominators? Well, they both look like they're factorable. So I'm looking for the factors. A is 1, so the factors of 56 that add to be 15. So when I think about 56, I know 7 times 8, and 7 plus 8 is 15, so that works out well. X plus 7, x plus 8. All right, and then over here, the factors of 42 that add to be 13, x plus 6, and x plus 7. All right, so then what would my common denominator be? Well, I noticed that they both share an x plus 7, so that's nice. They both have that piece. But then one has an x plus 8, and one has an x plus 6. All right, so what, if any, part does each fraction need? So over on the left, I have the x plus 7 and the x plus 8, so it needs the x plus 6. And over on the right, I have the x plus 6 and the x plus 7, so it needs the x plus 8. All right, am I adding or subtracting? Well, I'm subtracting, so I'm actually going to turn it into plus a negative. I'm going to bring the negative over to the 7 so that I don't lose it. And then what is my simplified numerator? So I am going to distribute that x. So I have x squared plus 6x. And then I'm going to distribute that negative 7. So I have minus 7x minus 56. And then I've got my denominator of x plus 7, x plus 8, x plus 6. Order doesn't matter, remember, when we're multiplying. All right, so I'm going to combine my like terms. So I've got x squared, and then I've got 6x minus 7x is negative 1x minus 56. And then I've still got x plus 7, x plus 8, and x plus 6. All right, can I factor the numerator? So it kind of looks like it could be factored. So let's think about this. What are the factors of 56 that subtract to be 1? All right, so 56 is 8 and 7, which is 1 apart, can be subtracted to be 1. So that's really going to give me, and I need it to be negative 1. So I've got 8 and 7. It's going to be plus 7 minus 8 because I need the 8 to be negative. And so in my denominator, I still have x plus 7, x plus 8, and x plus 6. And so can anything cancel? Absolutely. I see that I have an x plus 7 and an x plus 7. So my final answer is x minus 8 over, and it can't cancel because that's an x plus 8, x plus 6. And that should be my final answer. All right, so for example 4, I'd like you to do the first 2 questions on your own. So see if you can factor the denominators and see if you can identify what the common denominator would be. All right, so hopefully when you factored, on the left you should have gotten 5 times 2x plus 3, and on the right you should have gotten 6 times 2x plus 3. And so when I think about the common denominator, I can't make 5 look like 6 or 6 look like 5. The smallest number that I can make them be is 30. And then they both share that 2x plus 3, so that's nice. All right, so go ahead and I'd like you to do the next question. Pause the video and see if you can identify what piece each fraction needs. All right, hopefully you noticed that on the left, that fraction needed the 6, and on the right, that fraction needed the 5. All right, so go ahead and see if you can answer the next 2 questions. So determine if you're adding or subtracting, and then see if you can get that simplified numerator. All right, so hopefully you were able to get it down to where it's negative 22 over 30 times 2x plus 3. We cannot factor the numerator, but see if you can simplify that fraction any further. All right, so hopefully you're able to see that 2 goes into negative 22 and into 30, so that gives me negative 11 over 15 times 2x plus 3. All right, I think you're ready to try this whole step on your own. Go ahead and try example 5, see how far you can get. All right, so for example 5, hopefully you got to 3x minus 1 as the numerator, and then you have 2x plus 3, so x plus 3 squared times x plus 1. And I hope that didn't trip you up. They do share one x plus 3, but this one has 2x plus 3, so this one also has to have 2x plus 3s. All right, so example 6 is a little bit trickier, but I think you can do it. Now we have to look for a least common denominator among 3 fractions. All right, so with this one, hopefully you got to 4x minus 1 over x plus 5. So when I looked at it, I factored, the only denominator that could be factored was this last one, and it became x times x plus 5. While my least common denominator, this one has an x plus 5, and this one has an x. So these two have what this has. So my least common denominator is this, x times x plus 5. So this fraction needed the x, so I distributed, and I got 4x squared plus x. And I was subtracting, so I turned it into plus the negative. This one had the x, but it needed the x plus 5, so it became negative 2x minus 10, and then I brought down the plus 10 of the other fraction. So when I combined my like terms, I had 4x squared, x minus 2x is negative x, and negative 10 plus 10 cancel. And so I had 4x squared minus x. Well, can I factor my numerator? I could take an x out. So when I took the x out, I was left with 4x minus 1. And these x's canceled, and so that left me with my answer. All right, go ahead and try example 7 on your own. All right, so hopefully you were able to get x plus 1 over x minus 3. So the first fraction could not be factored, but the second one could, and they share an x minus 4, but they also have an x minus 3. So when I multiply the first fraction by x minus 3 over x minus 3, I end up with x squared plus x minus 3x minus 3 once I multiplied out, and this was subtraction, so I needed to add the opposite. So I subtracted x and I subtracted 1. When I combined my like terms, I ended up with x squared minus 3x minus 4, which I checked and it could be factored. And so the x minus 4 is canceled, and that left me with my final answer. All right, this is our last example for the notes, so go ahead and try this one on your own as well. All right, so this one was a little intensive, but hopefully you were able to arrive at 2x minus 5 over x minus 2 times x minus 3. So go ahead, if you didn't get that, go ahead and look over my work and see if you can identify where you went wrong and write any questions that you have. All right, so that's all for this video. I want you to write a summary. So what was this lesson about? What steps do you need to remember? What are your be sure to statement? And then what are 3 errors you think students tend to make when they add and subtract rationals? And then do you have any questions? Are there any questions that you want me to be aware of so I can make sure that we talk about those in our in-class discussion? Good job.